Now in section 9 Rust, we'll explore methods and traits. Methods are functions specially associated with new custom types. So if you have defined a struct, we can implement set of functions which are only available on that. So here we are creating a new struct called player with name and score as its field, and now we'll implement a set of functions which will be only available with this. So impl is the way to go with it. Now the new name is a constructor. It's a static method since there is no self passed as the parameters in it, and new is a general pattern to define constructor for implementation. And the self that you are returning is same as returning a player. Now defining a method with borrowed mutable self. So we'll update the score here with the provided new score value. And then show for a borrowed immutable self because we don't need to update the self here. So these are the signatures in specific cases that we'll be using. And after this, let's also show a owned immutable self and an owned mutable self. So say the game has ended and we just need an owned immutable self with end. We'll print the final scores of the player. That should do it. And after this, let's do an own mutable self where we'll update the score with the final score and then print the message. So update the score. Now we can print it again if part simply called self end. Now in the main, let's create a user John Doe and using the new constructor that we defined, and then update score few times, show score few times so that we get to see it when we run the game. 70, 30, let's add 10 and 5. Let's add an end after it to end the game. Let's have a new user called Jackie so we can showcase the end score as well, because we can't call end score after end as like it's already finished and will cause an error. We'll see that later. So let's run it for now. Scores are getting updated properly for John Doe and Jack Doe, like even if it was just one score, ran properly. Now let's see what happens when we run and again it'll show us an error. The ownership was moved. Okay. Now, so these are the different parameterized self that we saw in the implementation. And as we mentioned that the self abbreviated can be used instead of the struct name itself. So if we say return player here, that'll be like doing the same. So let's just quickly do it and run to see the effect. Same bit. Now let's move on to traits. So traits are primarily like interfaces, but not exactly. So let's write an example to see how and how not. So say we are defining a trait called file, and whoever has that trait should have a method generate. That is what this definition says. And say we also have a trait sign file. So when we say colon file, what it means is file is now a super trait for sign file. So anyone who has a trait sign file should have sign fin methods, but also generate. And the way we are adding where self size, that means we are actually adding a guard to the definition of fin, where self is size. So like if there's any other thing that we need to notify that okay it should be clonable or anything else, we can define it here. And the way it's not same is we're defining the default definition for fin within the sign file trait itself. So going ahead, when we implement the file trait on text, we don't need to redefine fin. So we have created two structs for a text file and for a docx file. Now we'll implement file sign file traits for both of them and see how it works. So let's implement generate for text. For now we'll simply print messages. We are not going to go into actually saving the content as a text file and as a docx file, because the docx file would be a pain for a simple example showing traits. So done with the generate. Let's implement for sign file. So this is a sign. I'll update the method name as well. Just re-implement these for docx. So we'll simply tweak the printed messages to reflect that. So when we run, we know proper one is being called. Let's update the sign file message as well. Now that we're done with it, let's go ahead. Let's go ahead and implement the dump file. Which will be the main function where we are passing a sign file trait implementation. So we can pass file text and docx both, and generate sign and done will be called on these. So let text content lorem, and then so we'll create a similar for docx. So dump file text will be accepted because text has a sign file implementation, and then docx content ipsum, and a dump file docx would work as well, because any of that trait is being accepted. Now let's just quickly run it and see. Oh, I forgot to rename the sign methods from what I remember. Yeah, let's quickly, the copy pasters generally avoid it, but yeah, let's quickly fix these. Cool, it's running as intended. So now let's move on to derive. So derive is you have seen us using derive debug lots of times on structs, which actually lets it being used as in println with debug print. So say similarly we can derive more implementations on it, like clone. So now what happening is docx has clone implementation, so we can do something like this: docx.clone, and docy has a clone variable value for that, so it's not owned. And doing this, we can see that if lorem ipsum gets done and the value is cloned. So yeah, as intended, now docy has lorem ipsum. So popular use cases like having serialization, deserialization. Now onto the exercise logger trait. It's a simple design log for logging utility which has a stderr logger struct, and then it wants us to define and implement a verbosity filter where based on the verbosity either a log will be printed or not. So let's copy paste the base of the example and then we'll fix it. So it has std logger, implemented logger for it, the do things which calls the logger. Okay, so let's copy the verbosity declaration from the initialization, so we have the proper values. So we have the definition for VerbosityFilter. Let's remove that. Now what we need to do is implement logger for it. So implement logger for VerbosityFilter, and for the function we'll define whatever the implementation that needs. So just copy from above so we don't mess with the signature. So if verbosity is less than self max verbosity, because that is what was intended in the example, it needs to print wherever the provided verbosity is less than the max verbosity defined. So it will pass it on to the std logger, otherwise not. Let's quickly run it and see. So it's only printing 2 because 3 is the max verbosity. Now let's make it 1, so 2 won't be there as well as intended. Now see, let's increase to 9 and let's run it now. Now both of the do logger should be there. Yeah, so it's as intended. Let's check the solution. Oh, that's the same as well.